Hey, welcome to The Explainer. Today, we are diving deep into one of the web's most common and kind of sneaky security flaws, cross-site scripting. It's one of those things that's hiding in plain sight, and it brings up a pretty wild question.
Yeah, I know. It sounds like something straight out of a spy movie, right? But what if I told you that a totally innocent-looking comment on a blog or a forum or even your own bank's feedback page could be a secret key for an attacker to get into your account? Believe it or not, that is the very real danger we're going to unpack today.
So, what is this thing? It's called cross-site scripting, or XSS, as you'll usually hear it called. At its core, it's all about tricking a website you already trust into running malicious code right inside your own web browser. It basically turns a friend into an enemy, and you'd never even see it coming. So the key word here, the absolute center of this whole problem, is trust. You trust your bank's website. You trust your favorite social media platform. And XSS attacks are designed to weaponize that trust. They turn the website itself into the delivery vehicle for the attack.
So the folks over at OWASP, that's the Open Web Application Security Project, they break these attacks down into three main flavors. And to really get a grip on this, we've got to look at each one. Let's start with the one that likes to stick around.
All right, first up, stored XSS. The best way to think about this is like malicious graffiti. Imagine an attacker sprays some malicious code onto a website, let's say in a comment section. The website server doesn't know any better, so it just saves it. And now? Well, now every single person who comes to look at that page gets that malicious code served right up to them.
Okay, so this diagram shows you exactly how this goes down. Step 1. The attacker injects some data with a nasty script hidden inside. The website, thinking it's just a normal comment or whatever, stores it away in its database. Then, you come along. You ask for that page. The website pulls that poison data right out of the database and sends it over to your browser. And the final step? Your browser gets this script, thinks, hey, this is from a trusted site, and just runs it. Bam! Attack successful. Okay, check out this example. It's kind of scary how well this works. So on the left, you see an attacker leaving what looks like a totally normal comment on their bank's feedback page, but buried in there is a script. Now look at the right. A bank employee logs in to check the feedback. Their browser loads that comment, the hidden script fires off, steals their login info, their session data, and quietly sends it to the attacker. And the employee? They have absolutely no idea anything just happened.
But wait a second, you might be wondering, how does that stolen info actually get from the bank's website to some random attacker's server? Well, browsers have this really important built-in security rule. It's called Cross-Origin Resource Sharing, or CORS, and you can just think of it as the bouncer at a club.
And this diagram really shows that bouncer doing its job. See, the browser is totally cool with a web page loading stuff from its own server. Images, fonts, that's a same origin request. It's on the list. But the second that page tries to reach out and grab data from a different server, that bouncer, CORS, steps in and says, whoa, hold on, let me check my list. So a big part of what makes these XSS attacks work is finding a website where that bouncer isn't configured right, where the door is basically left wide open, letting them sneak that stolen data right out.
Okay, on to flavor number 2, reflected XSS. So if stored XSS is like permanent graffiti, reflected XSS is more like a trick mirror. The nasty code isn't saved anywhere. Nope, this time it's actually hidden inside a link that an attacker tricks you into clicking.
So here's how that works. First, the attacker crafts the special malicious link. Then they have to get you to click it. Maybe it's in a phishing email or a social media message. You click it, and it takes you to a real, legitimate website. But the trick is, the malicious script is right there inside the URL itself. The website server sees that part of the URL and, without thinking, it just reflects it back in the page it sends to you. And just like that, your browser runs the script.
You know where you see this all the time? Search bars. They're a classic target. So picture a URL like website.com/search query equals and then a bunch of malicious script. When you go to that link, the website tries to be helpful. It'll say something like, showing search results for, and then it just prints out whatever was after that query equals part. And if the site isn't careful about cleaning that input first, it doesn't just print your search term, it prints the script. And your browser, it executes it. Game over.
All right, time for our third and final flavor. And this one is definitely the sneakiest of the bunch. DOM-based XSS. What makes this one so different is that the entire attack, from start to finish, happens right inside your web browser. I mean, the malicious code never even makes it to the website server. That makes it almost invisible to a lot of the usual security tools. So how on earth does that work? Well, it plays a trick on the way modern websites are built. It messes with something called the Document Object Model, the DOM. You can think of the DOM as the live, interactive blueprint of the web page that exists inside your browser. So a script on the page grabs some data from a source, let's say a piece of the URL, and it passes that data to a sink, which is just a fancy name for a function that can actually change the web page. Now, if that data isn't sanitized, if it's not cleaned up, an attacker can craft a special URL that tricks the website's own legitimate code into attacking you. The page basically attacks itself.
Take a look at this language selector, for example. Let's imagine this website uses a little piece of the URL to set the default language. Something like $default equals Italian. Well, an attacker could just create a link that says $default equals Italian and then tack on a malicious script. The JavaScript on the page could just grab that value from the URL, the source, and then write it directly into the page to set the drop-down menu, the sink. And in doing so, it accidentally runs the attacker's code.
Okay, so that's a lot of scary stuff, and I know it can sound pretty daunting. But here's the good news. This is a really well-understood problem, and developers have a whole arsenal of tools to fight back and build, a digital fortress against these attacks. And it all kicks off with one simple idea: trust nothing. The bedrock of any good XSS defense is built on two main ideas, and they both start with treating anything a user gives you as potentially dangerous. First up is encoding or escaping. You take any data a user gives you and you basically defang it. You turn special characters like those angle brackets for a script tag into their safe, text-only versions. So script tag becomes something the browser just displays as text, not as code to run. And second, you've got validation. This is where you get really strict. You create an allow list of only the things you expect. If you're asking for a phone number, you only allow numbers and maybe a dash. Anything else? Rejected. Simple as that. Now, for a really powerful, modern shield, developers have something called a Content Security Policy, or CSP. You can think of it like a very strict set of rules that the server gives to your browser for that specific page. These rules say, hey browser, you're only allowed to load scripts from this trusted place. You're only allowed to load images from that trusted place. This is huge, because even if an attacker manages to sneak a malicious script onto the page, a good CSP will just block it from running, or at the very least, block it from phoning home with your data.
And the beauty of this is how simple yet powerful it can be. Just look at this one line. This is a basic but super effective CSP rule. It's basically telling the browser, look, for everything on this page, scripts, images, the whole shebang, only trust stuff that comes from my own domain. That's it, nothing else. Just that one little rule can shut down a massive number of XSS attacks, right out of the gate.
All right, so we've gone through the three main faces of cross-site scripting: the graffiti, the trick mirrors, the whole deal. Let's boil it all down to what you really need to remember. It all comes down to where the malicious code lives. For stored XSS, that bad code is sitting right there in the website's database, just waiting for a victim. For reflected XSS, the code is hidden inside the URL. It's part of the link itself. And with DOM-based XSS, the attack happens entirely within the browser. The website server never even sees it. And all of this really points to one crucial central lesson. If you're a developer, the mantra you have to live by is never, ever trust user input. And for the rest of us, it's just a good reminder that the very thing that makes the web so amazing, how dynamic and interactive it is, well, that's a double-edged sword. It's the very thing that attackers try to exploit.
So, we've pulled back the curtain on one of the web's most pervasive hidden dangers. It really makes you think, doesn't it? Now that you know about this threat, will you ever look at a link or a comment section the same way again? Thanks for watching.